Okay, so we're going to work through our first example here, example 1. So when Leslie himself started doing this, he was examining a population of brown rats, which we're going to go through his actual first experiment here, how he learned to set up his model and whatnot. So in order to simplify the model, the following assumptions are made. So this is what allows us to be able to use the Leslie model. Only female population is considered. That's because we're talking about birth rates, and again, males can't reproduce. Birth rates and survival rates are held constant over time, and we know that that's not necessarily true, but we're just kind of trying to make a prediction here, so it's not 100% accurate, but it's going to give us a good idea of the population. The survival rate of a rat is the probability that it will survive and move on to the next age group. And as we're going to see, we're going to have our different percents or probabilities in our table. They're going to be given to us. We're not going to have to actually find those. The lifespan of these rodents is 15 to 18 months, so that means that once they reach that age range, they're no longer going to be able to survive. That's going to be like their dying out age. The rats will have their first litter at approximately 3 months and continue to reproduce every 3 months until they reach the age of 15 months. And that's important too because it tells us when they start reproducing, so when we start having a birth rate. So part A, it says, create a matrix multiplication P sub 0 L with a row matrix P sub 0, which is our initial population, and the Leslie matrix L to find the population after one cycle. Okay, so we're going to go ahead and set up that P sub 0 first. That's an easy one to do. So our P sub 0 is the initial population. So we have our initial population in our table right here for us. So all we have to do is literally just copy this row down. So I have 15, 9, 13, 5, 0, and 0. So there's that. That's my population matrix. I'm just going to put my Leslie matrix underneath it. Okay, so since this population vector has 1, 2, 3, 4, 5, 6 elements in it, or 6 columns rather, I know my Leslie matrix is going to have to be a 6 by 6 matrix. It has to be a square. So what we want to do is we want to make sure we keep them in the same order. So from left to right, I started from youngest to oldest. So when I create my Leslie matrix from top to bottom, it also has to go from youngest to oldest. So my population of 15 here corresponds to 0 to 3 months. So when I go ahead and I put my first birth rate in, that also has to correspond to 0 to 3 months. So that's a 0 because we were told in the explanation of the problem that they can't reproduce until after 3 months. So there's no birth rate there. It's 0. They cannot reproduce. And we just go down the list with the information that's given to us. It might not always be given to us in a nice pretty table like this. You might want to set up a table first though. So I'm just going to go down this list and copy them. So we have 0, I have 0.3, I have 0.8, 0.7, 0.4, and 0. Okay, so now these are actually probabilities. So what's already been done for us is these are percents that have been converted to decimals. So this 0.3 actually represents a 30% increase in the population. The 0.8 represents a 80% change in the population increase rather. All right, so there's our population increases, our birth rates. So now we need to fill in our survival rates. We also need to make sure we keep these in order. So we know the first row here corresponds to 0 to 3 months. So the first row has to have that 0.6 survival rate. So that 0.6 again is a probability. It represents 60% of that age range will survive from 0 to 3 months. So next to the 0 here, I'm just going to go in and fill in my 0.6. Everything else underneath it gets a 0. And this again just allows us to multiply the proper numbers together. So this one already has a survival rate, so I'm going to put in a 0. Go down to the next row, put in my 0.9, and fill in 1, 2, 3 more zeros. 1, 2, 3, 4 more zeros, sorry. So then I'm going to have 2 zeros, my next survival rate, which is another 0.9, and then I'm going to have 3 zeros underneath that. Move over to the next one, I'm going to have 3 zeros on top, then my 0.8, and then 2 zeros underneath. So I've got 1, 2, 3, 4, 5. I've got one more column to fill out. So I'm going to have 0, 0, 0, 0, and then I'm going to have a 0.6 and then 1 0 underneath that. So you notice that last row here has no survival rate because they are no longer living after the age of 18 months. It also doesn't have a birth rate. Now you can have a birth rate for the last age group. That's possible, but in this case, the rats don't reproduce in the ages of 15 to 18 months, so we do not have that birth rate here, which is fine. So what we would do here is we're going to go ahead and we're going to move on to the next step. we have to calculate that initial population after one cycle. So the one cycle is actually the length of our cycle. So since we're in months here, from 0 to 3, we know our cycle, I'm just going to put a little note here, put it up top. One cycle is equal to 3 months. And that's going to be helpful with some of our other problems, because they might not tell us to do a number of cycles, they might give us a number of months, or if our age is in years, they might give us a number of years, and we need to convert that number of months or years to cycles. So they already told us we're just going to do one cycle. So I'm going to use the equation from before up here, my initial population times my Leslie matrix to the n, where n is the number of cycles, and now we know that number of cycles is 1. So technically we don't even need that 1 there, because anything to the first power is just itself, but I'm going to write it out like that anyway. So we know that we are going to be finding here p sub 0, our initial population, times L, our Leslie matrix, to the first power. And we are just going to be plugging this into our calculator. And actually, let me rewrite that because I'm going to actually get an answer here. And our answer is always going to give us a new population row vector. So what you're going to want to do when you're putting this into your calculator is you're going to want to clear it out first, because we have all these zeros in this matrix, and it's going to be easier for us to put in if our calculator has already put those zeros in for us. So for us to do that, let me just move that over so you can see, you want to hit second plus 712, and that's going to reset your calculator. So you're going to go to your matrix, everything's clear, over to edit, and then the first matrix we're going to put in is our population matrix. So we're going to go over to edit, and we're going to put that in A, and I'm going to put a little note next to it so I know exactly which one it is, just circle it. And I'm going to put my Leslie in B, so I'm going to make sure I circle that too. Just a little note to myself. And this is a 1 by 6, so 1 by 6, oops, 1, 6. And I'm going to go ahead and put those different amounts of populations. I have 15 in the 0 to 3, then 9 in the next age group, 13 in the age group after that, 5, and then I know the next two are going to be zeros, but I'm just going to check to make sure the next two are zeros. So you can just hit second and then go back to matrix. And now we had to put in the Leslie matrix. We're going to go over to edit, and we're putting that in B. Make sure you don't override A. Hit enter, and we know that this is going to be a 6 by 6 matrix. And when I fill this in, I always do my birth rates first, because it's easier to just go down that column instead of having to search for where everything goes. So I know the first one's going to be 0, and I'm just going to hit down to go to the next one, 0.3. Down to the next one, 0.8, 0.7, 0.4, and then that last one is 0, so that's fine. Check your numbers before you move on. I'm going to arrow back up, and I'm just going to go ahead and fill these percents in, well, not percents, the decimals, along my super diagonal. So again, let me just mention, this is a super diagonal because it's not necessarily our main diagonal. The main diagonal would be this main diagonal of zeros here, and a lot of times, almost always, this is going to be the main diagonal is going to be zeros. The super diagonal is just the diagonal above your main diagonal. So I'm going to go over next to the 0, put in my 0.6. I'm going to hit down and over to go to the next one on the super diagonal, put in my 0.9, down over to the right. I'm going to put in 0.9 again because that's my next one, down and over, 0.8, down and over, 0.6, down. And I don't have to go over anymore because I am finished. So I'm going to go ahead and I'm going to go back out to the main screen now. I'm actually going to find the new population after one cycle, which again is 3 months. So I'm going to go to my matrix, and I need to multiply my population times my Leslie. My population is A, my Leslie is B. So I'm going to type in A, you don't really need the multiplication symbol there, times B, and I'm going to hit enter. And that's going to give me my new row vector. I'm going to move my calculator over and fill in my new row vector here. And a lot of times they're going to give you decimals, which is fine, but we want to make sure that we kind of try and keep it as accurate as possible. So I'm going to say around to about 2 decimal places if needed. Here mine are only about out to 1 decimal place right now, so I'm going to leave it to 1 decimal place. 4 and 0. Okay, so what this matrix tells us is how many of each how many rats are in each age group. So we can see we started with 0 rats in the 12 to 15 age group and 0 rats in the 15 to 18 age group. Well, now after this one cycle of 3 months, we now have 4 rats in the 12 to 15 months. So some of the rats from the 9 to 12 had moved up one of them probably has passed away, we can see, because they have a survival rate that is not all that high. Not 100% of them are going to survive. We have approximately 80% that are going to survive. So we've lost one in that cycle. And we can see how many have just moved up. So we had 13 in the 6 to 9, so that corresponds to the 11.7 in the new 9 to 12. So everything has shifted up one. Also, we've lost a few on the way, which is part of the natural cycle. So this is our new population after one cycle, which is 3 months. Okay, so part B, it says, how might you calculate the next population distribution 2 cycles using your Leslie matrix? Well, I have 2 different options here. I can go back to my original equation and instead just plug in a 2 for 2 cycles, or I can take the matrix that I already have and just multiply it by the Leslie matrix again. So you always have the option to go back to your original.
Teachers, pardon the interruption. At 9:30 bell, please let all potential football students for next school year report to the cafeteria. Again, at 9:30, all potential football players to the cafeteria.
Sorry about that. So we can always go back to the original equation, or we could use the population matrix that we already have and just multiply it by the Leslie matrix again, which does just about the same thing. So here I already have my new population matrix in there, and an option we can do is we could just multiply by the Leslie matrix again, but there's a little button here that says STO and with a little arrow, and what that does is it stores whatever matrix we just created into a new slot. So I'm going to hit store, and I'm going to go to my matrix, second matrix, and I know that C is empty, so I'm going to hit C, and then I'm going to hit enter. And what it did is it took that new population vector and it put it in C. So now I just need to take that new population and multiply it by the Leslie matrix. So I'm going to hit matrix, I'm going to go to C, and that has to be multiplied by the Leslie matrix again, which is in matrix B, and I hit enter, and then I know that that is after my second cycle because I've multiplied by the Leslie matrix one more time. So however many cycles you go through, that's how many times you need to multiply by the Leslie matrix. So my initial population times the Leslie matrix twice to the second power is equal to, and you just copy down all of these different population amounts for each age group. You're going to notice as you move forward in the cycles, you're going to have more and more decimals. As we're moving further and further out, we're multiplying by decimals. It's going to give us more decimals as we go. As we are approximating, and every time we approximate, it's going to get less and less accurate the further away we get. As we can see, it's going to take up a lot of room now. And my last one's 2.4. Almost ran out of room there. And there they are. 2.4 on the side.